Hello, and thank you for joining us this morning for the ASE2000 test set overview for the large-scale cutover simulation exercise for migration from one SCADA system to another. A quick introduction. My name is Larry Price. I'm a sales engineer for ASE, or Applied Systems Engineering. Today, my colleagues Darren Joes will be presenting and providing a demonstration of the new ASE2000 features. ASE was founded in 1988 and has been in the SCADA industry for a number of years and was eventually acquired by Calcatech in 2015. Both of our companies have a global footprint and representation across many electric utilities, providing communication solutions across various protocols. The ASE2000 test set is capable of master station simulation, DMP3, Modbus, IEC 6870-5-101, for example. You can also perform and create point simulation via the RTU mode of operation, and you can simulate a byte or bit protocol RTU, configure multiple responses to both controls and interrogations, polls, and scans. The test set also provides you with the ability to perform serial and Ethernet monitoring across networks to capture bidirectional communications between SCADA master stations and outstations in the field, or analyzing of communication errors, lack of response, timing of response, identifications of problem information being transferred, etc. Next slide, please. Today, we're going to cover large-scale RTU simulation using the ASE2000 test set. Previous ASE2000 test set features encompass simulation of single master stations and multiple RTU stations, but was limited in capability to simulate, say, 100 or 150 RTUs to more or less assess whether or not your SCADA client is polling properly and handling all those responses and processing information accordingly. So for large-scale simulation presently, with our new offering or new mode or features that we're offering, you can simplify the configuration effort or creation of multiple RTUs by using CSV files. And in those CSV files, or comma separated value files, you can specify the values to be reported back. You can sequence that in whatever fashion you desire to simulate various values being reported. And you can also provide status updates for commands that are being received by that RTU from the master stations. Other simulation features that are offered are via common separated values, or you can sequence multiple values, as I said, but you can also specify different timing intervals for polls and scans and their respective responses. And you can also toggle binary input values on and off, or increment analog values up or downward. A newer feature that we're working on in a future update will incorporate a built-in terminal server. This built-in terminal server will allow you to create or simulate an environment with multiple protocols in use across the same channel or different channels. It'll also allow you to have multiple serial protocols on the same channel, and you can convert via TCP to serial and back through this built-in feature. For scalability, this combiner splitter that we have in there will allow you to ramp up the RTU simulation to a large number of RTUs, and accordingly you'll have multiple ASE2000 instances simulating those RTUs. And also we're going to, as I stated, we're going to support multiple protocols on the same channel or different channel specified by the user according to your environment or application needs. So today's demo will be provided by Staren, and I'll let Staren take over and provide a quick overview of how this demo is presently set up in the environment.
Thank you, Larry, for the detailed introduction. Here in this simulation environment, because of the time limitation, we are using one PC for both master and RTU simulation. So in the simulation configuration, what we are trying to do is configure up to 10 RTUs and pull all these RTUs from the master. So that's a simple simulation sequence we have set up, but this can be scaled up to any level. And as Larry specified earlier, it can take any sequence of values through CSV files. It's a simple configuration to specify the CSV values for all these RTUs. And once that is done, ASE2000 can expose these values to the master, and polling and all these updates will carry all these simulation sequences. And also it can take commands and update the feedback to certain specified input points, so that way SCADA will actually get the status back after issuing a control. And in this mode, we also validate different type of control operations, like only the configured control modes will be allowed, like if a point or if a digital output is configured as select before operate, then it will not accept the normal operate command and so on. So all those restrictions will be in place. And similarly, there are a wide range of simulation features that you can see during this demo. First, I will explain the configuration files required for multi-channel simulation in ASE2000. So these are the configuration files I have already prepared. So let us go through them one by one. This is the first RTU configuration file. And if you expand the view, you can see that this is the CSV file. And there are certain columns to define the RTU names. So here you can see it's specified as RTU1. And here you can see the protocol. And further, there is a configuration required to specify the channel. In this case, I am using the loopback IP address and port number, but in a real scenario, you may use the real IP address available on the PC and the corresponding port number. And if you have a requirement to simulate multiple RTUs on different IP addresses, you may use the alias IP to configure these RTUs. And this channel is for the RTU address. Further, there are certain channels or columns required to be configured, and this is one of the important column to specify the point data type. And further, here you can see the point ID to be configured. And the other columns are optional to be configured. And here it explains the exchange required to run or attached to this configuration. So for example, here for point ID 1 to 9 digital points, these all are assigned to binary inputs. Similarly, all the analog inputs are assigned to analog input exchange. There are two binary outputs available or digital outputs available, and these are configured as direct operate and SBO operate respectively. And further, here you can see the analog output. These analog outputs are configured as direct output and select or SBO. You could also see that these digital output feedback points are configured here under description. So that means description field can be utilized to configure the feedback point for each controls. In this configuration, you could see that digital output 0 will be feedbacked to the digital input point 8, and digital output 1 feedback will be looped back to the digital input point 9. Similarly, analog output 0 will be feedback to analog input 8, and analog output 1 will be updated to analog input 9. So this is way you can configure the feedback point, but only difference here is that you cannot configure simulation for these points. So either you can choose to configure simulations, or you can use those points as feedback points for controls. So let us see the configuration of simulation points. As I have explained earlier, this exchange column is important. Here it attaches the specific data point to certain exchanges. And further, for the points that are required, the simulation values can be specified based on this format. And in this configuration, I have tried to toggle one data point in each iteration. That means when the first time the polling happens, the digital point 0 will be high, and further that value will go back to 0, and in the next iteration the digital input 1 will go to high. This goes on till the 8th iteration, and 9th and 10th iterations are left blank with value 0. So this is the configuration or simulation values for the RTU1. And for analog values, we have a different set of configuration. It's similar, but in this case we are trying to simulate value 11, 12, 13 and so on, and it goes up to 18. So that means analog input 0 will have a value 11, analog input 1 will have a value 12 and so on. So likewise you can configure all the RTUs. So I'll open a few RTU files and show you how the other RTUs are configured. Basically we have configured all the RTUs very similar. Only differences are the RTU names. So here you could see that RTU name is configured as RTU2, and further the protocol is configured, then channel ID is also configured. So here if you notice, compared to the previous RTU, this has got a port number specified as 45002. Previously it was 45001. So you can attach ASE2000 to any port number based on whatever is required. Yeah, this is one example where you could utilize multiple ports capability. And further, the RTU ID is specified as 2 in this case. But other configurations are kept exactly the same. Only difference being the analog input values. So instead of 11, 12, 13 sequence, here you have 21, 22, 23, etc. So this is a differentiation to find out whether this is RTU1 or RTU2. But in a real scenario, you might be interested to specify actual values based on your simulation requirement. And I will also open RTU3 configuration. This is more or less the same. Only difference here is that the RTU name is 3 and port number is different and RTU address is different as 3. And values are going from 30, 32, 33, etc. So if you notice, the configuration one file is dedicated for one RTU. This will help you to manage the configurations in a quicker fashion and also allow you to make very large scale configurations without any problem. But if you think that your simulation requirement is minimal and if you prefer to have all the RTUs specified in a single CSV file, that is also supported. Here you may specify all the points below on one RTU, in a second RTU, third RTU. Likewise, you can list down all the points in the same file. That is also supported. Okay, now let us go to the next file, which is a CSV file. And in this CSV file, you may specify the list of RTU files. For example, in this case, we have DNP3 LAN WAN RTU1, that is the first RTU to be configured, and further you have RTU2, RTU3, and so on. So this will help you to specify multiple RTU configuration files, in a segregated manner. Okay. Now there is a communication properties file. If you have a complex configuration and if you would like to manage the properties, communication properties in certain fashion, you may do that using the CSV files. This will allow you to specify whatever properties are available under ASE2000. Those can be exported and specified into the CSV. So in this case, certain configurations are exported and stored. So this way it will allow you can basically attach a specific combination of settings to a configuration. Now let us start the configuration process. Let us see how we can run these simulations. For that, you may open the command prompt, okay, and further browse to the location. So I am going to browse to this folder where we have the configuration files saved. Okay, so now we are in this folder wherever we have stored the configuration file. And to clean up the configuration, if you have created a lot of configurations in your system as part of the previous simulations, you may clean up that configuration using this command. It basically cleans the database file associated with ASE2000. So this is only required if you want to start fresh. In this case, you can see that the file is already removed. That's why it is giving the error message saying that it could not find the file. But in your case, if you have a specific file already created, you may clean up that file if you don't need those configurations. Further, let us provide the input of CSV files into the test tool. Okay, I will explain the parameters before executing this command. So the first parameter is the path of ASE2000 testset. You can see that it's C program files x86, ASE, and here the installation folder of ASE2000 testset, and further the executable name. Once the executable name or path is specified, then further there is a keyword to specify the configuration of communication properties. So here if you specify /COMM, that's com, for the name of the file. So whatever file name you have prepared, you may specify here to input the configuration of communication properties for this simulation file. Then further you may specify the input or index file as whatever file you have prepared with multiple RTU configuration CSVs. So you may specify that file here as a second argument to the executable. And a third argument is the output file to be generated after creating the configuration. So in this case, I have specified the output file name as dnp3_lanvan.a2k. So a2k is the file extension to save the project files with more information. So for this large scale simulations, you will have to create the configurations based on this a2k files. It will attach the database files and other related information to make it as a complete file. So that way you can move this simulation file from one PC to another without any problem. The existing format Monex will not include several information like database and other things, but this A2K file will allow you to carry the configuration in the entirety from one PC to another. Now let us create the project file A2K. For that I will execute the command. Once the command is executed, ASE2000 is started and it will load the configurations one by one from the configuration files. So as you can see here, it has already loaded 10 RTU configuration files from the CSV files. Now it's in the process of creating the configuration, and you can see that it has already created all these RTUs. So under each RTU we had certain number of points, and all these points are already created in the point database. So here you have RTU address 1, 2, 3 and so on. Further, it also creates the exchanges required to run the simulations. So here to explain the scenario, we will locate the first RTU. First RTU has a lot of exchanges configured under it automatically, and here you can see the channel. So channel could be, as I mentioned earlier, this could be a real IP address and port number, but in this scenario we are using the loopback IP address and a specific port number. And here RTU address 2 has got a different port number to identify its channel, and further you may also find the corresponding simulation properties under each exchanges. For example, in binary input section you will be able to see these simulation values in an encoded fashion. So whatever configuration is provided in CSV file, that is encoded in a specific format, which is a kind of compact format for extended simulation sequences that is specified here. Similarly, if you go to the analog input, you will be able to see the analog point configurations. So all these informations are encoded in an optimized fashion to reduce the project file size, and that allows ASE2000 to load the configurations in a much faster pace. Now I will explain how to run these configurations. So before closing this configuration, I will explain the other exchanges like direct operate, select relay and operate relay, direct output, and select and operate and log outputs. So these exchanges are automatically created from the configuration file based on those inputs. So now let us see how we can execute this configuration. We could start ASE2000 with the project file directly. So in the previous case, we started the ASE2000 with inputs as communication properties file and index file, and it was told to create an output file as A2K. In this case, we could ask ASE2000 to load the configuration from this A2K file, which is created just now. So now let us start the ASE2000. It loads the configuration from the A2K file. It's loading all the information, and everything is exactly same as earlier. It has loaded all these configuration from the project. So if you want to repeatedly run the simulation, then this would be a faster way. The previous command allows you to convert the CSV files into a project file, and this command allows you to load the configuration from the project file. Now let us run one more instance of ASE2000, and that way we can do a loopback simulation. So here I'll switch the mode to RTU. So this ASE2000 will use an RTU instance. Now I will use the up arrow to pick the same command once again. So ASE2000 has a feature to run same configuration as both master and RTU simply by toggling the master RTU switch. So at the bottom you'll be able to see several options to toggle the switches. So you may use those options to toggle the mode of RTU simulation. So here on the right hand side you can see that it's configured as a RTU, and by default when ASE2000 loads a project, it starts with master mode. So if you want to switch between modes, you may use these buttons here. Now I am going to show you how to run the simulation. So as you can see, both exchanges are exactly the same at both sides. These are loaded and ready to execute. And the simulation, from a simulation perspective, RTU side is more important with all the simulation values. While running as a master, it will not use any of these values. So it will simply pull the information from the other side. So now let us see how the simulation works in a real scenario. To invoke the simulation, you need to execute the ASE2000 using the start button. Now at this point you can see that the communication line or communication indicator is on and it is moving. So that means RTU under all these channels are ready to accept communication from remote masters. Now let us switch to master and run the simulation. So to make things easier, I will switch to the point list and run the simulation. So while running the simulation, you could see that all these exchanges that are invoked will be highlighted in specific colors, and you could also see that the simulation values are activated based on the sequence. So here, based on our previous configuration, we remember that in RTU1 the values will be toggling from digital point 0 to digital point 7, and digital point 8 and 9 are reserved for controls. So you can see that all these values are being simulated appropriately. If you look at the RTU2, you will be able to see a different set of values that were configured. Here you can see that these values are switching from 21 to 28. And if you go to the RTU3, you could see that here the values are in the range of 30s, and in RTU4 these values will be in the range of 40s, and it goes on for all the RTUs. So whatever values that are simulated will be sent to the master based on the simulation sequence. So this is how multiple sequences are simulated in each of these RTUs, and the same can be pulled from master side and exposed as needed. Now I will stop the simulation to show you the control functionality and the updates. So let us go to the RTU1 and go to the exchange list. So here, if you look at the direct operate relay command, it is mapped to digital input 8. So if the control comes to the RTU, and if the command reaches here, that is the corresponding value has been feedbacked to digital input 8. Now this RTU is already running and we have stopped the simulation, so you can see that all the RTUs are disconnected from master. Now let us trigger this command and see how it is functioning. Now I will select the direct operate relay, and here if you open the configuration, this configuration matches our CSV, and here it says the latching relay and the value is on. Now let us see how this functionality works. To invoke the command, I will run this option, and you could see that the value is updated here after receiving the control information. Similarly, you may do a command on the second point, and once you do the select and further operate, you can see that the second digital value is also updated. Similarly, we could issue a control for the analog value as well. So here in this case we could make the analog value say 11. Currently the value is 0, and if you issue the analog output, you can see that the value has been updated as 11. Similarly, you could do the same with select before operate analog output. So this explains the control feedback capability and comma separated value input capability in ASE2000 to simulate large number of RTUs under different communication channels. In earlier versions, ASE2000 used to support only one communication channel, and because of that limitation, large-scale simulation of RTUs was not possible. With new ASE2000, you will be able to simulate any number of RTUs, and the simulation sequence also can be configured in a user-friendly fashion. You could use the CSV input to configure the simulation. I will also explain another option to simulate or control the simulation sequence. So in this example, you could see that the values are configured for the polling. So that means whenever master polls or get the information, the simulation is invoked. So there is a different option available in ASE2000 to control the simulation with an interval. For example, here if I specify the simulation interval as 10, this is in seconds, so the simulation values will be changing only after the expiry of specified interval. So in this example, I will change this value to 10. So if when we run the simulation, other points or other RTUs will be simulated based on the polling rate from the master, And here you can see that this this simulation sequence will be changing based on this interval. So this is a live functionality. That means you will be able to change the simulation scenarios in real time when the RTU simulation is running. So I'll make the same change for analog values also, so that we can see the simulations consistently. So I'll make this also 10. So now you know that RTU1s will be simulated at an interval of 10. That means the values will switch from one value to another only after 10 seconds. So this way you will be able to control the simulation sequence. Let us go back to the point list, and this time we will expand the view a little bit more to see multiple values from different RTUs. Okay. So in this simulation sequence, let us run the simulation and find out how the simulation works. So I'm going to start the master. Now master will start polling the values. So you can see that the simulation will be invoked in every 10 seconds in this case. Previously, it was configured to do the simulation based on the polling, but now the simulation will be changing in every 10 seconds. So this is another way to control the simulation sequence in ASE2000. You will be able to manage the simulation scenarios using this mechanism. Yeah, that covers the demonstration part. And so we have a few questions posted by participants. One of the question is, yeah, can we get a copy of this presentation once it is completed? So yeah, definitely we will share the video of the old presentation once it is formatted, and we will share it to you after a day. So that means tomorrow at the same time you should be getting the video link to watch the same. And the next question we received is how serial RTUs are simulated in large scale. So yeah, what we do for serial is a capability that we described earlier. We have a serial to TCP converter built in. That means all the serial protocols will be sent over the TCP channels. And if you have a SCADA that is capable of sending serial protocols over TCP channel, then you will be able to utilize ASE's built-in terminal server capability and receive responses through TCP. That means all the serial protocols available will be streamed or made available through TCP ports. And there is another query on how multiple protocols are simulated, since ASE2000 can one instance of ASE2000 can simulate only one protocol. Yeah, we are utilizing a capability called a TCP splitter. There is a communication splitter which will be available along with this server version, and that TCP splitter will channel the traffic through one communication port to multiple ASE2000 instances. So if you have a communication line that supports multiple protocols, then this TCP splitter will be handy, and it can channel the protocols into different ASE2000 instances running in a server machine or a normal desktop machine. So the instance that is configured with the specific protocol will be responding to those queries. So that way you can either have different protocols simulated under different RTUs or same protocol, simulated under different RTUs. So you have the flexibility to define the configurations. And we received another question: what would be a real life example where you would use this simulation? What type of problem? Yeah, we are mainly proposing this requirement for large scale SCADA cutover projects. We recently are doing one of the projects here in California, and the requirement was to replace the SCADA, and before making the new SCADA operational, they want to check each and every point whether it is available or not. And for that purpose, there was no requirement. So using our new methodology, there is no need for scripting or complex configurations. Whatever sequence user like, it can be easily configured using CSV files. And there is a compact CSV format available. If you notice the demo, you might have seen the multiple values supports star configurations. That means if a value is getting repeated over and over again, you can specify certain formats and make the configuration really compact. So once we release the software, you will have the user manual explaining all these details. But yeah, the volume of the configuration will be much minimal and will be encoded in a very compact fashion. And that way you will be able to carry or save the configurations quickly. The next question is how to find communication error and rectify. The advantage of ASE2000, as you know, is the line monitor capability. It always displays the communication messages in the live monitor, and all the details can be viewed in respective panes. And in this case also, it will be exactly the same capability. Whatever feature you are seeing, those will be updated under the line monitor, and you will be able to troubleshoot the scenarios quickly. So that means if you have polling coming from different channels, all those traffic will be displayed in the line monitor, and even in the RTU simulation mode, you'll be able to see all these traffic without any problem. And you can save with a new ASE2000, you will be able to save the configuration into local text file. That means earlier versions had a limitation that we could save only a limit of files. But new version allows the rolling files capture capability, and that will allow you to configure multiple files or a set of files to save the traffic. So later you may load these traffic from this traffic capture file and view the details. The next question is, do we need to mind about the channel bandwidth and latency here? If so, what are the constraints? Yeah, in one TCP port or one physical port, you might have a limitation, like if it is 100 Mbps or 1 Gbps, you might have a restriction likewise. So it is specific to the hardware capability of the PC where the ASE2000 is running. And if you have 1 Gbps network port, then you should not have a problem, because most of the scenarios can be handled with 1 Gbps. And there is also a hardware requirement from the processing perspective. That means the CPU should be decently capable to run these instances. And the RAM requirement on the other side will be much lesser because of the compact, for configuration formats that we use. We don't use much RAM, and you will be able to execute all these instances on a normal workstation PC. So that means you don't need a server or a very high volume configuration PC for this. You can simply use a laptop or a workstation for simulation. That's the other advantage of ASE2000. Yeah, we don't have any further questions posted. So yeah, if you have any additional questions, feel free to post and we'll be able to answer it as early as we could. So Larry, do we have any other points to cover during this demo?
No, thank you.
Yeah. Yeah, we see one more question here posted by somebody. Yeah, it's the question is when this version will be available. Yeah, this version we are carrying out the test with a utility, and once the version is tested out, we'll be once the beta testing phase is completed, we will make the beta version available to the general public, and we are planning to make it as a beta version so that you can try out at your side and give the feedback if it is available. But and once it is once the testing cycle is completed, we will be able to release to all, but beta version will be available earlier than the final release. I think that's all we have for this demo. And yeah, so Larry, if we don't have any additional points, maybe you can wind up the session.
No additional points. You provided a lot of detail there, so thank you. And thank you for participating today, everyone.
Yeah, thanks for the participation. And as I told earlier, we will make the video available to you by tomorrow, almost the same time. And please go through it. And since it is it was a short video, yeah, it is difficult to grab all the details. But yeah, if you go through the video, you'll be able to understand more details.
And as Darren said, after you review the video, if you have additional questions, just please reach out to us and we'll get back to you. Thank you.
Yeah, that's all for today. Thanks everyone for participating, and see you next time.